This is an introduction to logical subscripting in MATLAB. You may be familiar with numerical subscripting in MATLAB. Here's an example of numerical subscripting. Let's define A to be a 5 by 5 matrix. So here are some pseudo-random values generated for A. You may be familiar with the numerical subscripting where we say A parentheses 3, 4, and that's going to return for us the third row and fourth element of this matrix A. Or we can also say, let's just get all of the third row. So for the column specifier, we use this colon operator where it specifies all columns. And so there's the entire third row. Similarly, we can get, for example, the fourth column of the matrix A. And again, this is numerical subscripting, but we can use the values in A to subscript A logically. So, for example, let's list all the values in A that are less than 1/4. So I'm going to make a new matrix B, and here we'll say A, and we'll put in a subscript, but the subscript is a logical condition where we say A is less than 1/4. And here you can see we picked values out that are all less than 1/4. We can also do assignments through logical subscripting. So let's make B equal to A once again. But now we're going to set all values of B that are less than 1/2 to be 0. So the way I do that is B, and the logical index is B less than 1/2, and then the assignment is equal to 0. And as you can see, that operation has taken place. Now let's show a more interesting example. Let us call up a figure. I'm going to dock the figure, and I'm also going to call up an editor. So here I'm going to call this file logical subscripts. I'm going to save it. And I'm going to start by defining t, a time vector, with a variable number of points. And we'll let y be cosine 2 pi t. We can plot y with respect to t, and I always like to set line width to 2, and I also like to set some properties for the current axes. GCA gets the current axes, and I like the font to be Times, and the font size to be a little bit bigger than normal. I often go for 24, but here let's try 18. And so I ran that script. I'm going to at least set the label here, the x-axis label. I always like to use the LaTeX interpreter. It makes nice axes labels. Let's just make it a little bit bigger really quick. Okay, so here's my plot, and let's make this signal so that it saturates at 1/2. So to do this, I'm going to make a y2 which is equal to y, and I'll say y2, and it could be y is greater than 1/2, or it could also be y2 is greater than 1/2, it doesn't matter. And we'll set that to be our saturation value of 1/2. And then actually I'm going to move this right up here, and then I'm going, instead of just plotting y, I'll plot y and y2. And now we're also going to want a legend. And its argument, I'm going to call it legend string, and we're going to specify its location southwest. Okay, so I had to define legend string. It's a cell. The first element is y, and the second element is y2. I also need to say set my legend interpreter LaTeX. And let's run that, see how that goes. Okay, so you can see here I have y in blue, it's the original sinusoid, and y2, it saturates at 0.5. We can even just pick out the points that are, say, less than negative 0.75. So here's how I will do that. I'm going to say y low is all the points in y where y is less than negative 3/4. And to plot these, we need a t vector that's the same length, so I'm going to call it t low, and it's going to be t where y is less than negative 0.75. So it's the same subscript but for a different vector, and that is just fine. So after the plot command, I'm going to type hold on. This is going to enable me to plot to the same axes without overwriting it. And then I'm going to type stem t low and y low. And I'll just pick line width 2 also. And I'll turn hold off. Hit run. And you can see it's plotting all these points where y is less than negative 3/4. And maybe the point spacing is a little too dense. I'll reduce this to 201 points. Let's see how that works. You can start to resolve the individual points here. Okay, so that's a brief example on logical subscripting. In my next tutorial, I'm going to show you how I can use logical subscripting to make a periodic signal.